Yeah, thanks for the nice introduction. Yeah, the big cloud-native FaaS Lebowski. Probably you took my talk because of the title. Huh? I thought I do a talk in Berlin. Let's go crazy. Let's do a crazy title. Let's do a crazy title slide. Yes. Perhaps a few more things about me. So yeah, I'm Leander Reimer. I work in Munich. Okay, I live almost in Austria. I work in Munich, but not many people know that I'm actually a Berliner. Yeah, I'm born in 1977 here in Berlin. I had the chance to see my mom yesterday, so thanks for the invitation. Yeah, I'm a senior developer and architect. I program and build systems for more than half of my life. I turned 42 now. I had my first job with 15 in computer science. I'm a total cloud native nerd, as you can see from my t-shirts, microservices, Kubernetes, cloud native, everything. I think the stuff that's actually happening in computer science at the moment is just awesome. The last 4 or 5 years, how software engineering, how software architecture evolved, you know, from old systems now to, well, more microservice-based system and function-based system. This is just awesome. Open source, I think open source is great. Building proper products, proper systems for customers, like BMW. I work for BMW quite a lot. Using open source software, this is great, and exactly in this context, we will dive into today and have a look at open source cloud-native FaaS frameworks, so function as a service frameworks. So we will not talk about Lambda or Google Cloud Functions or all the commercial stuff. Who's building microservices in here? Excellent. And who's building function-based systems already? 2 brave ones. Okay, so just to set the scene. Well, for me, you know, from a software development perspective, I think serverless is, for me, the next logical evolutionary step in software engineering. If you remember where we came from, you know, maybe in the 2000s, you went to Hetzner, you bought a server or you hired a server, you installed the server manually. This was proper hardware, right? So you installed the hardware, you got an SSH access, you installed your PHP application on this, your MySQL database, your Apache server, and all that stuff. Then we kind of evolved, right? Infrastructure as a service came. We did virtualization, so we didn't have any hardware anymore. We had virtual machines. From virtual machines, we then kind of evolved in the last maybe 5, 6, 7 years towards more platform as a service based approaches, right? So Kubernetes became popular. You had Apache Mesos or Docker Swarm. The whole containerization came. This again changed the way we built software. Of course, this had an influence on software architecture. We went from monolithic systems to more microservice based systems, and if you look at the current state now, right? If you do microservices, well, you have to know a lot, right? You have to know Docker, you know, have to write Docker files. You know, microservice-based architecture is not so simple either. There are shitloads of frameworks around. There's Quarkus now and I don't know, Spring Boot and all those frameworks. So the complexity you have at the moment as a software engineer is quite high, right? There's a lot of stuff you have to know. And this is why I think that the idea of serverless, yeah, taking away the idea of servers anymore, taking away all those things like, oh, I need containers, I need to pack my application into a container. All this is, for me, the next logical evolution, okay? So to make our life as a software engineer and as a software architect easier again, right? Take away all this infrastructure stuff we don't want to care about, right? We want to build software and not infrastructure. This here is a definition. It's from the Cloud Native Computing Foundation. They say serverless computing refers to a new model of cloud native computing enabled by architectures that do not require server management, right, to build and run application. It leverages a finer-grained deployment model. This is what we talk about today, where applications bundled as one or more functions, right? So we decompose our applications into one or more functions. Those are uploaded to a platform and then executed, scaled, and built, especially in response to the exact demand, okay? So this pay-per-use model, if your function is called, then you pay. If it's not called, you don't pay. So this is what the Cloud Native Computing Foundation has to say. Now, maybe a few words about functions, right? I mean, in the serverless ecosystem, I mean, serverless is big, and function as a service is only one small part of serverless, right? And functions are the preferred serverless application programming model. Yeah? You don't have to do functions in a serverless world. You could still do kind of containers or microservices. But functions are the preferred serverless application model. Do they still teach the EFA principle in at universities? Eingabe, Verarbeitung, Ausgabe? Do they still teach that? I was taught it, at university. So this is like the proper definition of a function, right? So the function is super old. It's one of those eternal truths in computer science, right? You put data in, then you have this function, this repeatable operation. You put data in, then the function does something to the data, and it spits it out again, and you have your output. Super easy, super stateless, right? Repeatable. And this is why it's so ideal for this whole cloud-native environment, right? If you look how we decomposed our systems, well, maybe a few years ago, we were at the very top level, right? So we had our systems, and there was no decomposition. I hope you built it component-based, but you deployed it monolithically, right? You had one big, humongous application. And then we soon realized, well, if the monolith crashes, you don't have anything, nothing runs anymore. So in terms of resiliency and robustness, the monolith was not that good, right? Of course, you could have scaled it and clustered it. And then we started to decompose our systems, in subsystems, maybe microservices or self-contained systems. You maybe a bit further down right now at the moment, if you do it on a component level, you have your good old microservices, quite popular at the moment. And what we now do is decompose our systems even further, right? Down to the service level, down to the function level where we then have our function services. Now, why we do that? Well, on the left-hand side, you have kind of the pros, okay? Of course, you are more flexible to scale, right? With microservices, this was already pretty good. With function services, you're even better, right? You can scale on a function basis, right? If you have certain functions that are called quite frequently, you can scale those a lot more than maybe other functions that are not used so much. You have the benefit of runtime isolation, right? If one function crashes, well, then only that certain part within your whole architecture is not working. Compared to like the monolith, if that crashes, you don't have anything. So you definitely have a better runtime isolation in terms of crashes, in terms of slowdown, and all those things. You could have independent releases, deployments and teams, right? So not only decomposing your system using functions or microservices, you could also decompose your teams, if you like, your dev teams. And in the end, what you want is a higher resource utilization, right? So this is kind of an ops and maybe a money perspective, like when you came from a server time, you bought a big monster server, you put your monolith on it, and maybe on 2 hours a day, you had like a utilization of 40%, and the rest of the day, the machine usually idled. So those opportunity costs were really high, okay? So to decrease the opportunity costs, you want this higher resource utilization. But on the right-hand side, we see, well, going this way, well, there are some trade-offs, of course, right? Distribution depth, for example, right? So distribution depth. If you do microservices and maybe synchronously talking microservices, then suddenly latency plays a role, right? And yes, there is latency in a network. Consistency sometimes is data consistency is not so easy anymore in a distributed system, right? Increased infrastructure complexity, increased troubleshooting complexity, and increased integration complexity. And because I don't want all this, of course I want some form of platform, right? That hides all the complexity, that makes this complexity manageable again. So we need some form of platform to not have that much of those trade-offs. So we talked about serverless, we talked about functions. One more thing I would like to, from an architecture point of view, I would like to tell you is the good old event-driven architecture. I mean, this is an architectural style that fits super into a function as a service model, right? So you have functions. How do functions communicate? Asynchronous, right? Using some form of messaging. Of course, there are other types of triggers as well, right? But it ought to be, loosely coupled and reactive. Your functions react to events that happen within the system, right? And well, in all fairness, we should actually also build our microservice architectures more loosely coupled and reactive, but for some reason we usually let them talk via REST, which is maybe not such a good idea. So, loosely coupled, reactive, software components and services, this is what we want. There is a CNCF project called Cloud Events at the moment, so you may want to have a look at Cloud Events. What they try to standardize is how those events look on the wire, what the envelope is, which certain attributes are important. So Cloud Events is currently a CNCF project underway. It's already pretty far. Right. Then let's have a look at the serverless landscape, right? The Cloud Native Computing Foundation, I think you know the big landscape of them. This is like the Cloud Native landscape. And now they realize that this whole serverless part is getting quite some attention and is getting really big. So what they publish now is a separate serverless landscape, right? What you see here, they divide this into platforms, frameworks, tools, and security at the moment. And we will have a look at the platforms mainly. And you see, whew, those are quite some logos. I haven't counted them. We only have 38 minutes left, and we will not have a look at all of them, of course not. So let's define some criteria how we can kind of break down and well, compare those platforms. Well, first thing, open source, right? I said I'm open source enthusiast. I don't want to pay any money. And if you're in like enterprise projects, it's always good if you don't start the conversation with the customers like, oh, I have this huge product here, but by the way, it, I don't know, costs €500,000. So no initial cost would be super, and no vendor login, please, if possible. Maturity, of course. If you are kind of in a consultancy business, maybe, then maturity is important, right? What you want from an open source project, you want a good, vibrant, active community, right? Where there are quite some people involved, little issues, okay? So please no bugs. Frequent releases would be nice, just to see is the project lively, is it a valid project? Maybe the use cases. Well, is it more of a general purpose platform? Is it more for enterprise usage? Is it maybe more for big data processing or artificial intelligence? Maybe edge computing. I always like to bring my cloud with me, okay? So edge computing, also, you know, putting functions on low power devices like 5 Raspberry Pis in this box here is definitely a use case, yeah? Put your functions towards where the data happens, towards you know, the sensor data. Super use case for function as a service. Approachable, right? So for us as a developer, how hard is it to get started with this thing? Yeah? Is it hard to get it installed? Is it hard? Does it have proper quick starts? Does it have proper examples? And yes, a bit of documentation would be nice, right? So we have a look at this. Language runtimes, yes, please more than JavaScript. And has anyone seen this brave talk from the 2 young ladies yesterday with JavaScript on the back end? Yeah, I'm more on the Java side, so please more than JavaScript. Developer friendliness, right? We have a look at are there any tools and frameworks and a local runtime, right? Can I develop locally, or is it only possible to develop like in the cluster or in the cloud, which is, I think, kind of important to have this local runtime ability. How's testing done? Is there an IDE integration? Do they have any IntelliJ plugins or something? So developer friendliness is kind of important. Operability, yeah, easy setup, supported platforms, technology footprint, kind of important. Yeah, imagine you have this FaaS operated by your customer already or internally in your company, and you come with this humongous platform, and maybe your ops team tells you, no, you probably need a separate cluster for this one. Or, yeah, so how lightweight is it? Integration. So what are the triggers that are supported by the platform? Does it have support or kind of plug-in ability for certain infrastructure components like Istio, for example? Plugins, standards, all this stuff. And finally, of course, performance, okay? We want good startup performance. We want good cold startup performance for our functions. And of course, we want, if possible, a good and high throughput if we call our functions regularly. So quite a catalog, okay? So how do we get started? Well, let's go back to our landscape, and well, we cross out those. That was easy, right? So half done. Those are the hosted solutions, but what I'm not saying is that they are to some kind of that they're not suitable or that they're bad, okay? But they're hosted, okay? I mean, they're products. They're operated by by Google or AWS or Azure or whatever, and they all have their point, but they're not open source, okay? So first criteria not fulfilled. So let's have a look at the installable ones. Also here in the installable ones, there are a few products, okay? AppScale, LaunchBadger, and Galactic Fork, and they don't fit quite into this FaaS framework category. So we cross all those out. I crossed out a one from VMware, which only runs on VMware. Dispatch is called, and AI Pipeline is a serverless platform for, well, doing artificial intelligence, so not function as a service as well. So we're left with those. The next thing I'm going to cross out is at the bottom right, this one here. This is called Virtual Kubelet. It's a serverless platform. What you can do with Virtual Kubelet is extend your Kubernetes cluster and offload certain containers to AWS Fargate, for example. So you can have kind of a virtual Kubernetes cluster that can be dynamically extended by AWS or other cloud providers. Awesome project, but nothing to do with function as a service. Now the next three, I would say, are technically not a function as a service platform. And this is Knative, Riff, and Reimer. I don't know if I spell it correctly. Now Knative, super hot, super new, in my opinion, not production ready yet. And as I said, it's not a function as a service platform. Knative is more a framework to build function as a service platforms, okay? So what do? Well, they have three parts: build, serving, and eventing, right? Build is that part where you imagine I have a certain function, somehow I need to build this function within my serverless framework and my serverless platform later on. So this is what build covers. Serving, what they have here is a scale to zero request-driven compute model, okay, on the basis of Istio. So Knative is not a small framework, so it's based on Istio. Istio is huge already, and now they put Knative on it. But what you can do here is kind of this, especially this scale to zero request-driven thing, right? If no one calls your function, if no one calls a container, then nothing runs. This is what you want. So serving is important. And eventing, I said, event-driven architecture is kind of the architectural style you should adopt. Eventing provides those composable primitives for event sources. Project Riff builds upon Knative, and what they do is they bundle it with another CNCF Foundation project, which is called Cloud Native Build Packs. Right? So if you are maybe used to a Cloud Foundry approach, what they have is like build packs. So for certain language runtimes, they have kind of a build environment that allows them to build a Go function or a Node function or a Java function within a cloud native environment. So this is Knative Riff, more infrastructure type things. And Reimer is currently definitely a full-blown serverless platform. Version 0.8, built by SAP, I think. They work on it heavily. They currently plan to migrate away from Kubeless, which we're going to have a look at, and migrate it to Knative and Istio. So I will not have a look at Reimer, because Reimer is super huge, but I recommend that you have an eye on all those three things and what's happening here, because this is the future, I think. Okay, then we're almost done, and we have 6 left. And those are our contenders. Open Whisk from IBM, Apache Open Whisk is an Apache project in the Apache Incubator at the moment. We have Fission, FN Project. FN Project has been, I don't know, announced by Oracle 3 years ago at the Oracle Java 1. The last Java 1, they announced it. So this is kind of the function as a service framework from Oracle. We have Kubeless, Nucleo, and OpenFaas. Okay? So let's have a look at those 6. Now, don't be scared with all those tables. We don't go through all of them, but this is mainly for your reference. I say a few things. So the first thing what I did is I did a open source quick check. Okay, I had a look at the web pages. I had a look at the GitHub sources. I had a look at the source code. I had a look at the community, just to find out how lively is it, what's the quality like, are there many bugs, things like this. The table at the moment is sorted by age. So Open Whisk is probably the oldest from beginning of 2016, closely followed by FM project. Well, they started the project way earlier, but the first real activity is somewhere in May. And Nucleo is in June 2017, so the youngest. All of them are Apache 2 license, which is good, and OpenFaas is MIT. So on the open source side, everything fine. Contributors. What I counted with contributors is the stuff how many commits have them. How many committers do they have? Just to find out, is it like a one-man show, like OpenFast, for example? There's this one single committer, okay, who does most of the work. I mean, there are 97 other committers that maybe submitted a few patches or something, but behind OpenFast, there's this one, Alex Ellis, I think is his name called, and he's super crazy. For 2.5 years, he's been actively working on OpenFast. No bugs, almost no open issues, which is really good. You see on the releases, also quite good. I don't know what FM Project does with their releases. They have on GitHub over 1,000 releases. I don't think they get their tagging right because they have every version number twice, one with a V at the beginning and one without. So, a bit strange. They have 15 bugs. Unfortunate Open Whisk, for example, I don't know. The build is broken. It doesn't build. They have quite a few issues and open bugs. So from that point of view, you already see, most of them are lively. If you look at the GitHub stars, then OpenFaas would be our star, followed by Kubeless and Fission, right? And the others are slightly behind. What we could also do is, of course, we can do a Google search. So I did that, Google Trends. From that point of view, I would say, OpenFaas is the blue one. Denmark is OpenFaas country. They don't use anything else. France is OpenFaas and Open Whisk. The UK, Kubeless, OpenFaas, and Open Whisk. And in Germany, we're pretty even, OpenFaas, Kubeless, and Open Whisk. So undecided here, right? But for some reason, Fission, for example, doesn't even, has a few spikes. So Fission is not very popular, and FN project also not very popular. Right, so let's go to the next table. What do we have here? Well, you see here now a first ranking. I put Fission first, Kubeless second, then OpenFaas, Nucleo, and Open Whisk and FN project last. Language is the language they're built in. So almost all of them are built in Go, which I think is for an infrastructure platform component, a super language to go. Open Whisk, for some reason, is built in Scala. That's probably the reason why it's not building anymore. Use cases, I would say most of them are kind of enterprise use case. OpenFaas and Nucleo, they say they also cover the IoT use case. So edge computing, fog computing, low power devices. And by Open Whisk and FN project, I think they're actually for hosted environments. I mean, IBM, the IBM offering in the IBM cloud, cloud functions, they're based on Open Whisk. And Oracle, as you all know, is also trying the hosted cloud market, and they're also looking for a own offering of functions, and probably it's FN project based. So those are the big ones that are powered by corporations. The generation bit is, do they do everything when I show you in the demo? The first generation is like when you do the CLI, all of them have a CLI, and if you build a function, what you have with the first generation, you say like function build, function push, function deploy. Okay, so you get my point. So you realize, hey, I'm actually building a container here, I'm pushing the container in a registry, and then I'm deploying the container within the platform. This is what I call generation 1, because it's kind of the old style. And with the second generation, you don't see all of this anymore, right? You just say function deploy. and the code goes to the platform. The platform takes care of, putting this bit of code into a container or whatever, building the stuff, deploying the stuff, and so this is generation 2. I would personally say generation 2 is the future. Okay, so on that part, OpenFaas is not so modern anymore. But remember the IoT use case. You probably cannot get this whole building stuff onto a low-power device like this. So generation 1 has its purpose, in my opinion. Most of them support Kubernetes, of course, the almost de facto standard. Some of them can be deployed in plain Docker or Docker Swarm usually. They have Nucleo, for example, has good support for AWS and GCP, so Google Cloud Platform. Open Whisk, they say OpenShift, which is kind of Kubernetes-based anyway. Right, so covered there. I think it's okay if you only support Kubernetes at the moment. Runtimes, those are the language runtimes they support. And you see here, all the major languages are there, right? You have Node.js, you usually have Python and Ruby, Go, what do you have else? A few of them support JVM languages, Ballerina, for example, C#, Java, Java 8, so pretty mixed, right? I guess on that part, you just have to pick the framework on the language you're planning to implement your functions in. But good support there. On the trigger side, this is like the stuff that can trigger your functions later on. For the big ones, you have cron, HTTP, NAT, which is a message queue, Azure Queue Storage, Kafka is usually always there. Right? Well, Kubeless doesn't have, Kubeless has Kafka support, Fission has Kafka support. OpenFaas and Nucleo, in my opinion, are concerning the triggers the best, right? Different things, cloud events support here already with OpenFaas, which I mentioned earlier. Here you have RabbitMQ, MQTT. For the IoT use cases, MQTT is probably the queuing protocol you want to use. And FN project at the moment only HTTP, right? So they have some work to do. Okay, well, enough of those tables because kind of boring, and we have 23 minutes left. Oh, I have another table. Why do I have another table? Well, this is kind of the summary. We can skip this one. I kind of already voted them here. So you see, I think Fission has a super good README. Installability is super. You have 2 Helm charts. Quick start was easy. You have pretty good performance, 820 requests per second on a Hello World Go level. Nucleo is super dead fast, right? Over 1,000 requests per second. README is okay. Installability was not so nice because you had to install it via Kubernetes YAMLs manually. No Helm chart there yet. Kubeless, Helm charts and YAMLs, OpenFaas, Docker Compose YAML, also Helm chart. FM project is like the tractor concerning performance. I don't know what they do, 48 requests per second. I mean, compare this with 1,000, right? I mean, I know which one I would choose. At the moment, OpenFaas is the only one with Raspberry Pi support, right? So if you want the IoT use case, then definitely go for OpenFaas. I think Nucleo is working on the support on them on the roadmap. Okay, yeah, let's do some demo magic. Right. So I have a cluster running in Google Cloud Platform. I did the basic setup. I show you the link later on, okay? If you want to try this out, everything is on GitHub already, okay? There's this huge make file here, so which kind of helps you to set up everything. So you do like make cluster and make Fission install, and then it installs everything. I already did that, right? Just to show you. So let's start. Let's see, kubectl get namespaces. Ooh. Let's see. So what you see here already, we have Fission installed. Fission comes in 3 different namespaces. The Fission namespace is like the core namespace where the core components are deployed. Fission builder, well, guess what? Probably the building takes place in that namespace. And Fission function is the namespace where your functions will be deployed later on. I find this approach kind of orderly, separating things with a namespace is, I think, a nice idea. Nucleo, you see, is one namespace at the moment. OpenFaas has also this one main OpenFaas. Can you actually read this? I can do this a bit bigger. And the OpenFaas FN namespace. So let's have a look. On Fission. And you see Fission, if you do the full install, is quite heavy, okay? So they bring a lot of stuff, but they're a full-blown platform, right? So they have their Prometheus for monitoring and metrics. They bring a message queue trigger. They have the logging, a InfluxDB to store their metrics and the logs. So in my opinion, they're very sophisticated, okay? If you don't need all of this, Fission provides you with a core installer as well that does not bring all those additional infrastructure components. So you can slim down Fission quite a lot. Okay. So here's a README if you want to go through all of this. Now, what you do in Fission is usually this here, okay? So Fission has this notion of something called an environment. So let's do this. So what is an environment? For every language you want to build your functions in, you need an environment. And what this environment does is kubectl get all -n Fission function. Now what you see here is the environment at the moment fires up so-called pool managers, okay? Those are not the actual functions, but the functions will be executed within those pool managers later on. And this is the approach Fission took to kind of take down this cold start approach. So they claim they have a cold start of a new function in 100 milliseconds. And the reason is because they don't fire up the function from zero. They put the function code into one of those pool managers. The pool managers are always hot, right? And thus the functions fire pretty quickly. So what you see here, there is an environment you can create environments for JVM, for Node, for Python. So every time you want to support a new language, you have to install one of those environments, right? Now let's deploy and create our super simple, we do this here. Our super simple function. Oh, okay. This happens if you don't follow the README. Okay, so this was pretty easy, right? We let this go. So what you see here, this is like what a function in Go looks like. Yeah, I know, super hello world. But on that point, you don't have to have any special layout and any special package at the moment. All you need at the moment is the net HTTP package. You define the handler. The handler gets a response writer and the request object in. Sometimes they also pass a context object in where you get additional metadata from the runtime. But this is all you have here. Now let's see. Is our function deployed? So, hop. So the package name, what was the package name? This here is the package. Okay, so this is the log output. Status succeeded. What you see here a bit is what it actually did. So what you see here is like the log output of the building of our container, or the function. Don't not say container. So Fission function list. Let's see. Up. So function is there. Everything good. Now let's test. So you see, you use Fission, for example, using their Fission CLI. And this is something they all have, right? If you want to use Nucleo, well, then it's NuCTL. If you use OpenFaas, you have OpenFast CLI. So they all have kind of their own CLI, like kubectl, to operate with it. So function is running. We could call it. So this is good. The next thing we do is we create a route for it. So in this Kubernetes cluster, I have an ingress installed. And what this basically does is now create an HTTP trigger, creates an endpoint add my ingress, and then we should now be able to call our function using HTTP. Let's see. Hop. Hello from Fission. Okay, so that kind of worked. Let's see what the startup performance is. Okay. So we do a small load test now. Okay. So we say, hey, we do 50 concurrent connections and we do 1,000 requests. What you see here, it's pretty fast. So if you look at the histogram, you're kind of in this 100 millisecond region, right? Which is pretty good. If we do that again, you're even faster, right? So the pool managers are warmed now, the functions are fired up. So if we repeat that, this is kind of nice and fast. Okay. I think I had one more test. Right, we do this here. So we need to wait 30 seconds and I can drink something. Any questions so far regarding Fission? Okay, 14 minutes. Oh, that's a long 30 seconds. Maybe I should have only done 10 seconds. Okay. So here, for example, this test now had 794 requests per second, which I think is pretty decent, right? So nice and fast. Okay. Then we say Fission delete. I destroy Fission now because Fission and Kubeless cannot be installed in the same cluster because they kind of share the same resource names. So I say make Kubeless install. Okay. Make Kubeless. Well, maybe we switch to Nucleo because I think Nucleo is really nice. Is one of those hidden gems in my opinion. It's totally unpopular. You can't find anything on Nucleo at the moment, and it has a small community. But they put a lot of effort in, I would say. It's nice and lightweight. So Nucleo was during this evaluation was one of my hidden gems, and Fission, right? So those two maybe. So we install Kubeless install. Right, so we skip the Kubeless demo. As you see here, I kind of was playing, if you have a look at the commands, it's pretty much the same here, okay? We install Kubeless, we say Kubeless function deploy, we pass it a Go file, we specify the runtime, we can specify some CPU limits, then we use the CLI to call the function, for example. Then again here, Kubeless trigger HTTP create. So what we're doing here is create this external HTTP trigger again. So pretty similar to the Fission approach. You can say Kubeless autoscale, so you can tell Kubeless to autoscale this function. And the main difference with Kubeless is the following. What Kubeless actually only does, it takes a function, it sticks it into a container, and then creates a standard deployment config, replica set, and a pod for your function. Okay. Now, if you are a function as a service enthusiast, then you would say, well, where's the scale to zero approach? Because there's always a function running in Kubeless, right? So you always have this one pod running. So from a payment point of view, you would have to pay for this one instance that's running. So currently what Kubeless does not support is the scale to 0-bit, right? They can scale up, but they cannot scale to 0. Maybe when they integrate with Knative or Istio, that's probably possible in the future, but not right now. Similar approach to Nucleo, okay. So let's go into the Nucleo package. Nucleo, let's see. I think this is already running. kubectl get all -n nucleo. So you see here, Nucleo also takes this approach, right? What you see at the top is you have a deployment called hello Nucleo. This is the deployment config of our function. You have a replica set. You have what they automatically create is a so-called horizontal port autoscaler and a matching service for this. So same here, okay? But they claim they support scale to 0, but I did not get it to work. So maybe the fault is on my side, or probably. But you see here again, all they do is kind of are an abstraction of onto Kubernetes. So you don't have to write all the YAML stuff, and they do all this for you. What's pretty amazing on Nucleo is the performance. This was seriously the fastest in the whole test. Yeah, so it's even slightly faster than Fission before, right? No, not now. I mean, of course, it varies. If we do the benchmark test, let's do this one here. We only do 10 seconds. Okay. So again, 50 connections, 4 threads for 10 seconds, and let's see what we get. Right. In that case now, 897 requests. So definitely a bit faster than Fission. In my initial measurement, I had over 1,000. Well, of course, this can vary. Right. Then, well, OpenFaas, pretty much the same. As I said, OpenFaas currently is the only one that properly supports low-power devices using Docker Swarm on Raspberry Pis, for example, which is really nice. Here, what you see in the console output, you see that it's this generation 1 bit, right? So you see FaaS build, FaaS push, and FaaS deploy. So you have this 3-step thing which you actually don't want to do. FN project, the final one. Well, that was the one from Oracle. Installability, well, okay. They have a Helm chart. You could install all this. Now, the biggest problem with FN project is how they do the scheduling of the actual functions. If you deploy this in your cluster, and if you call the function, what you don't see is anything happening in the Kubernetes cluster. And the question is, how do they do their scheduling? And the answer is, well, they mount the Docker socket and they they start the containers via Docker directly. Okay, so they completely bypass the Kubernetes scheduler. And I think this is a stupid idea to do, right? So probably Kubernetes is just not the operational model for them. Pretty much the same for Open Whisk. Open Whisk, for example, also does its own scheduling, bypasses Kubernetes scheduler completely. So for those two, I would say, even though you can install them on Kubernetes, I think they're not made for Kubernetes, right? For something else. Okay, 6 minutes left. Time to wrap up, I would say. So I hope you saw a bit of the magic of those frameworks. And the big question is, well, dude, which one is the best now, right? So let's see. And I would say Fission and Nucleo are definitely my hidden gems. They are both the unpopular ones, but from a technical point of view, maturity point of view, documentation, performance, quality of the code, wow, they're definitely good. And I would say pick one of those two. Pick Fission if a complete platform is what you're looking for, including Prometheus and everything. I think Fission is definitely very mature. Easy installability using a Helm chart. If performance is what you're looking for and more lightweightness, because Nucleo in a base install, this is only 2 components in a Kubernetes cluster, okay? So the component footprint, I would say, in the cluster is super low, it's super lightweight, it's that fast, has many triggers. If you look at their roadmap, quite promising roadmap. They're working on a Visual Studio Code plugin, for example. They're working on a serverless framework plugin at the moment. They're working on the Raspberry Pi support. So give Nucleo maybe half a year time, and then Nucleo is definitely super to use. Kubeless, well, yeah, it's fast, it's lightweight, and it's very simple. Maybe that's enough sometimes. Maybe if what you're looking for is just an abstraction of Kubernetes, then maybe Kubeless is your choice. Because in the end, all they do is, is create deployments within the cluster. Okay, I don't have to do that manually anymore. OpenFaas is definitely very popular. Currently the only one, at least, that supports ARM devices like this one here. But Fission and Nucleo are definitely worth a look at and would be my recommendation if you would ask me. All the code, if you want to play around, it's the makefile, the README, so all the steps for the 5 I had a look at. For Open Whisk I did not do a demo, but for the other 5, if you want to play around, this is all you need is a Google Cloud account. Have a look. If you want to build one of those on your own, have a look at the second URL. And thanks for listening, and it's time for Q&A.
Thank you so much. So, do we have some questions? Yes. To the end.
Hi, thanks for the talk. Did you consider putting Pulumi in the comparison?
No, I know that there was a talk yesterday, but since I kind of did the selection based on the CNCF landscape, Pulumi is currently not on there. This was probably why I did not consider it.
Okay. Do we have another question? Oh, here in the front. Todd. Before we come to the next question, I guess you already noticed it, but we have a schedules change. So at 11:25, we exchanging 2 talks from Jan de Vries from Gallery and Thomas Derriman from Loft. We are switching them. So we also announced it on our website and also on Twitter. But now let's go to your question.
Thank you for the talk, very interesting. I have a question about the performance measurements you did.
Yeah.
It looked like this was local. Did you try that on different cloud providers? And did you experience different performance measurements?
It was definitely not local, so okay. So I ran on my machine the benchmark tool, of course, but I did fire against the ingress of the Kubernetes cluster. Everything ran in GCP at the moment. I think Google Cloud Platform is, in my opinion, almost the fastest out of there. But no, due to timing, I did not use AWS or Azure at the moment. So, but I think if you fork the repo, and if you're more on the AWS side, all you have to change is like exchange the creation of the Google Container Engine or Google Kubernetes Engine with firing up Amazon Kubernetes Engine. This is the only part, and the rest should work. Install Helm, install the components, and then do your own benchmarks. I think this is 2 hours work.
Thank you.
Do we have another question? In the front.
Yep. So if you run your Kubernetes in a cloud, so why not to use their function offerings directly?
Well, I think where those installable products come from is like this integration part, right? If you come to a customer, I work for large organizations, and they all have their own Kubernetes or OpenShift PaaS within the system. And I think before we go to a fully serverless world, I think you will see hybrid solutions where you maybe have a mix of microservice architectures, and for certain use cases, for nice event-driven use cases, for data processing use cases, you maybe have a valid function as a service use case. And I think then it makes sense to have one of those frameworks on top of your PaaS, which you have in your company anyway, right? But you're right, you're totally right. If you are in a public cloud anyway, and you don't have anything on-premise, then you're probably better off with the commercial offerings by the cloud provider of your choice, right? But I think it's either you're in public cloud, then it's good to go with the public offerings, or you have something on and maybe an ops team that manages their own cluster, then those installable frameworks are a choice.
Okay, so we are at the end. So thanks a lot again, and give him a warm hand of applause, please. Thanks. For your talk. Thanks. So the next one is at 11:25. It's Serverless New World by George Mao from AWS.